Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor with respect to physics for coming classes. Today we are going to discuss a third lecture of the units and measurement. In third lecture we are going to discuss about the dimensions and their applications. In previous classes we have discussed about the what are the dimensions, how dimensions for any physical quantity can be derived, how that can be used, and we have even used one application of dimensional analysis, that is how to convert certain quantities from one system, that means SI system, to CGS, and let's say from CGS to FPS, something like that. So today we are going to discuss about the second very important application of dimensional analysis. Let's begin. So today we are going to do about to check the correctness. Today we are going to check the correctness of the given physical quantity. Whatever the physical quantity, is it correct or not? Even we can say this is the consistency check of a physical quantity. So let's say it's how we can do it. Let's take an example only. Here we have given S is equals to ut plus 8 half at square, where S is the, you can say, displacement, u is the velocity, generally we say this is initial velocity, t is the time, a is the acceleration. This is all that has been given. They have given that this is the relation. You just check the correctness of this physical equation. So what I need to do is I need to take the dimensions of left hand side. This is S. Now what is it? It is a displacement. So I know displacement comes under the category of an distance, or it is under the this category of length. So dimensions of displacement would be L to the power 1. So I have written S is equals to L to the power 1. Now I need to solve the dimensions of right hand side equations. So on the right hand side I can find it out. It is a u into t. U is the velocity. What would be the dimensions of velocity? It is meter per second. This is its units. So this is L to the power 1 and divide by second. So this is t to the power minus 1 multiplied by time t. So this is again t to the power 1. So this becomes L1 t minus 1 plus 1. So this comes to an L1 and t to the power 0. So here I have written it is an L. Let's do it for half at square as well. As you know, this is half, which is a constant number, and any constant number does not have a dimensions. So I need to just write it down, the dimensions of a and t square. What is a? It's an acceleration. What is its units? It's a meter per second square. Acceleration, it's in meter per second square. So this is L1 t to the power minus 2 multiplied by t square. This is t square. This is L. So as you can see, on the left hand side dimension is L, on the right hand side dimensions is L. So when dimensions are equal on both the sides, so what we can say that this relation is dimensionally correct. I hope these things are clear to you. Is it clear? Okay, let's move on to the next. Suppose I need to find out the correctness of a physical condition. The relation that has been given is, let's say they have given kinetic energy is equals to p square divided by 2m, where p is the momentum and m is the mass. I need to find out the correctness of this relation. How could I do it? Let's first take it about the kinetic energy. What is its formula? It is half mv square, where I need to write its unit. Mass can be represented as kg. Velocity, but it is a square of an velocity, so I need to write it's in kg meter square per second square. So for kg I should write m1, for meter square I should write L2, for second square t to the power minus 2. So this is the dimensions of kinetic energy, which is our left hand side. Now I need to find out the dimensions of right hand side quantities. P square, it's in momentum square. What is momentum? It is m square v square. M square, it's a k g square multiplied by meter square per second square. So if I make a dimensional formula of this, I should write m2 L2 T minus 2. It is an m2 L2 and T minus 2. And next would be the mass. Mass is m 1 L0 T0. So this is a dimensional formula. This is a dimensional formula of mass, and this is the dimensional formula of p square. Now I need to take a ratio of this p square by m. Here you might have observed that 2 is a constant number, and we do not write an any dimensional formula for any constant. So I have just omit the 2. Same case is here for half as well. So this is p square by m. So p square by m were the p into L2 t minus 2 divide by m1 L0 t0. So on an upper side it would be an m2, on an below it would be an m1. So what I should write is m1 L2 t minus 2. Now this is the dimensions of right hand side. Now look at this. Dimensions of left hand side, it is m1 L2 t minus 2. Dimensions on right hand side, it is m1 L2 t minus 2. So this relation is dimensionally correct. This relation is dimensionally correct. Get it? Okay, let's try one more relation. Let's try it. Suppose you need to find out the relation, or you need to find out the correctness of the relation, which is v square is equals to 4 into a into x, where v is the velocity, a is the acceleration, and x is the displacement. V is the velocity, a is the acceleration, and x is the displacement. You need to find out the correctness of this relation. Again, let's begin with the left hand side. V square, it is meter square divided by second square. So the dimensions would be m0 L2 t minus 2. Let's move with the right hand side. Acceleration, what it would be? It's in meter per second square. Yes, correct. So this is m0 L1 t minus 2. X, it's in displacement. It would be in meter. What it would be? It's an m0 L1 t0. So when I multiply a and x, don't need to multiply 4 as it is a constant. A into x, so it would be an m0, here L1, here L1, this is L2, and this is t minus 2. So let's check at the dimensions of left hand side. It is m0 L2 t minus 2. Let's check at the dimensions of right hand side. It is m0 L2 t minus 2. Both sides having a same dimension. So this relation is dimensionally valid. But I need to discuss one more thing, that do this relation is correct physically as well. Do this relation is correct according to the physics as well. Now look at this. According to the physics, the relation is v square equals to u square plus 2ax. If I put u equals to 0, why and how I can put a u equals to 0, that we learn and discuss in next unit. But let's say if u is equals to 0, then the relation according to the physics is v square equals to 2ax. And here what we have derived, or what we have checked the consistency, is v square equals to 4x. Even though relation is not valid according to the physics, this is dimensionally valid. So please do remember the following things. If any relation is valid according to the dimensional analysis, then that relation may or may not be valid according to the physics. But if any relation is valid according to the physics, then that relation must be valid according to the dimensions. So please do remember this thing. It is possible that relation is valid according to the dimensional analysis, but this is not valid according to the physics. Why this arrive? This arrive because when there would be a dimensionless constant, let us say this is 4, we cannot derive this 4 as a relation, or we cannot check its consistency as well. So error would be arised. Yes, even look at this point. It is 1 by 2. It is 1 by 2. It is 2. So when there would be a constant number, when there would be a constant number, we cannot check dimensionally that number, and that's why there are chances of an occurrence of an error. But if any relation is verified, or any relation is valid according to the physics, then that relation must be valid according to the dimensions. I hope this seems clear. Okay, let's move on with one more numerical and check it. Let us suppose you have been asked that find out the correctness of the relation that is power P is equals to F into V. So where F is the force and V is the velocity. This relation is absolutely correct according to the physics. Now let's check it on the dimensional basis. Now what are the dimensions of power? What is power? It is work done divided by time. What is work done? It is force into displacement. You can say its formula or unit would be kg meter square per second square. For time it would be a 1 by second more. So this is kg meter square divided by second cube. So if I make a dimension of this, it is m1 l2 t minus 3. This is the dimension of power. Now I need the dimensions of force and velocity. For force, it is kg meter per second square. So the dimensions would be m1 L1 t minus 2, and velocity, it is meter per second, so this is L1 t minus 1. So when I multiply f into v, when I multiply f into v, this is m1, this is L1 into 1. I need to multiply this too. I hope these things are clear. Multiplied by t to the power minus 2 and minus 1. This is minus 3. So look at the dimensions of this thing. This is m1 L2 t minus 3. Look at the dimensions of this as well, m1 L2 t minus 3. As this relation is according to the physics and according to the dimensions. This relation is according to the physics and according to the dimensional analysis. This is valid. Now I hope these things are clear. So those relations which are correct, which are valid according to the physics, they must be valid according to the dimensional analysis. Those relations which are valid according to the dimensions, they may or may not be, they may or may not be correct according to the physics. Is it clear? Okay, great. Let's move on. Next, jump to the next application, which is application number 3. I need to find out, I need to find out to check the correctness, or then to derive a relationship between different physical quantities. We have learned two applications. First was to convert a physical quantities from one system to another. Second was we need to check the correctness of a given equation. Now this is third one. To derive a relationship, we need to derive a relationship between different physical quantities. First, go through the data. What all are given? They said the period of oscillation of the simple pendulum depends on mass m of the bob, length L of the pendulum, and acceleration due to gravity g at that place. I need to derive the expression for its time period using method of dimensions. So what they have given is the time period of a pendulum depends on mass, but we don't know the power of that mass. Depends on length L, again we don't know the power of the length, and this depends on the g. It's an acceleration due to gravity at that point, at that place, but again we don't know the powers. So what I'm going to do is I just give them a certain powers. This is A, this is B, this is C. Now my task would be to find out the value of A, B and C. So if I write this three relations in a single, I can write like this. Look at this. T is equals to K multiplied by M to the power A, L to the power B and G to the power C, where K is a dimensionless constant. K is the dimensionless constant. Now what I should do is I should write it down the dimensions on both the sides. So dimensions of time, what it would be? Can you get it? Yes, it's an M0 L0 T1. Now K is a dimensionless constant, so we don't need to write the dimensions of the K. Yes. Next, M. What is M? M is the mass. So dimensions of mass, it's an M to the power 1. So I have written 1, and as in power A, so I have written A. Next, dimensions of length, it's an L and its power is B. So here it is. G, acceleration due to gravity, basically it is an acceleration only, so its formula, its unit would be a meter per second square. So this is L1 and t to the power minus 2 to the power C. Now what we can do is we need to add those things which are having a same base. So here it is an M to the power A, here L is B, and here even it is L to the power 1. So this is L to the power C into t to the power minus 2C. So I should write it as an MA, L to the power B plus C and t to the power minus 2C. So now let's move on. What we can do now, what we are supposed to do is we are going to compare the exponents, we are going to compare the powers of m, l and t on both the sides. So if you remember this thing, it is having an m0 l0 t1 equals to, sorry, equals to ma l to the power b plus c and t to the power minus 2c. This is the relation that we have get in the previous slides. So here, this is m, this is m, base are the equal, you can compare their powers. So a equals to 0, so I have write it down. Next, this is b plus c and it is power 0, so I have write it down, b plus c is equals to 0. Here it is minus 2c and here it is power is 1, so this is minus 2c is equals to 1. So what I get is, what I am going to achieve is, this is minus 2c is equals to 1, so this c is equals to minus 1 by 2. If I put c is equals to minus 1 by 2 in this relation, b plus c is equals to 0, I will get b is equals to half. So previously we have used this m to the power a, l to the power b, and that is the l to the power a, again t directly proportional to the m to the power a, l to the power b, and g to the power c. Yes, so power a, it's in 0, so m to the power 0, l to the power b, b is having a value of half, so it is 1 by 2, and g to the power c, it is having a value minus of half. So I can write it like this: t is equals to k under root of l by g. From experiment we know that k is equals to 2 pi, so I'm going to write this is t is equals to 2 pi under root l by g. Now let's understand the beauty of this application. You don't know what is simple pendulum, you don't know its theory, you don't know how it works. Even though you don't know anything, you can find it out the relation. This is the capability of a dimensional analysis, and this is a very good application. It will help you at various stages of 11th and 12th. So please do remember these things. Okay, so let's revise this, how we have done it. What we are about to do is, we just write it down what is given. Here I have been given time, this depends on the mass, this depends on the length, and this depends on the g. G is the acceleration due to gravity. So I would write it down the dimensions of each one. I have write it down the dimensions of time, I have write it out the dimensions of other things. Next I will just add it up the same basis, and at last I will just compare the powers of same quantity. So if I can compare the powers of m, I can compare the power of l, I can compare the power of time, and I hope these things are clear. So let's move to the new numerical. Look at this, what they have given, read it very carefully. They have given the centripetal force F acting on a particle moving uniformly in a circle may depend upon mass m. So let's write it down. F depends on mass m, this depends on velocity v, and this depends on the radius of the circle r. So let's give them an arbitrary powers. So this is m to the power a, v to the power b, r to the power c. Now we are interested in a, b and c. So I can write like this: f is equals to k into m to the power a, v to the power b, r to the power c. K is a constant having no dimensions. K is a constant having no dimensions. Now what should we do? We should write it down the dimensions. What would be the dimensions of force? It's in kg meter per second square, so it is m1 l1 t minus 2. What are the dimensions of m to the power a? M, what was it? It is mass, so this is, it is m1 l0 t0 to the power a, so this would be m to the power a, L to the power 0, t to the power 0. Next, v to the power b. Velocity, it is an m0 L1 t minus 1 and to the power b. This is m0 lb t to the power minus b. And last radius r, it's an m0 L1 t0 to the power c. So this becomes m0 L to the power c and t to the power 0. Now what I should write? I should compare them. So let's move to the next slide. The force would be m1 L1 t minus 2. This is equals to m to the power a. It is an ma L0 t0. It is ma L0 t0. Next, length m0 lb t to the power minus b. And radius, that is m0 lc t0. Now I should add it up. Here it is m to the power a, here it is 0 0, so I should write it as an m to the power a. Next, L to the power 0 plus b plus c, so I should write b plus c. Here t to the power 0 minus b and 0, so t to the power minus b. Here it is m1 L1 t minus 2. So I can compare the components, I can compare the powers, I can compare the exponents of the same physical quantities. Here it is a, here it is 1, so this a is equals to 1. Here this is b plus c should be equals to 1, and this is minus of b is equals to minus of 2. So I can write it down, thus b is equals to 2. If I put a value of b at here, so this is 2 plus c is equals to 1, so c becomes 1 minus 2, which is minus 1, and a is equals to 1. So what I can write it is f is equals to k multiplied by m to the power a, having a value 1, v to the power b, v to the power b, and value of an b is 2, and r to the power c, having a minus 1. So I can write it as an k multiplied by mv square divided by r. Here experimentally I can find it out, k is equals to 1. So the correct relation is f is equals to mv square by r. Now look at again, this is a relation, for centripetal force, and this force do exist when and when a particle is moving on a circular path. Now let's look this again. You don't know what is particle, you don't know how its velocity would be related, and how it is moving in the circular path, and why it is moving in a circular path, but you know the relation. Yes, don't you think this is great? Yes, this will help us. So do remember this application. Let's move to the one more application of this, and I suggest you to do at yourself at your itself simultaneously. Do it. First, read it very carefully. The given data is displacement by particle x. This depends on acceleration a and time t. Here only two variables are there. I have given a power a, it's an acceleration to the p, and time t, a power of q, and I need to find out the relation between these three quantities. Now let's do it quickly. X is the acceleration, x is the displacement, sorry, so this is m0 L1 t0. A is the acceleration, it's in meter per second square, so this is m0 L1 t minus 2 to the power p. So this becomes m to the power 0 L to the power p t to the power minus of 2p. And time, it's an m0 L0 T1. Here the power given is Q. So this is M0 L0 T to the power Q. This is the time. Now I need to just multiply this too. So this is X, it's an M0 L1 T0. Acceleration would be M0 LP T minus 2P. Time, it's an M0 L0 TQ. So this is M0 0 TQ. So here it is an, let's multiply this. This is M0, this is P, this is 0. So this is L to the power P. This is minus 2P plus Q. This is T to the power minus of 2P plus Q. And this should be M0 L1 T0. So here it is 0. So 0 equals to 0, that we know already. L to the power P, P is equals to 1. And here the relation is minus of 2P plus Q should be equals to 0. Now I am having a value of P. So this is minus of 2 into 1 plus Q is equals to 0, and thus Q is equals to 2. So if I put up a relation or value, X equals to A to the power 1 and T and T to the power 2 and multiplied by K, which was a dimensional constant. Experimentally, K is equals to half, and thus X equals to half into A into T square. This is the relation. Yes, very good. Let's move to the next. Let's find out one more numerical like this only. We have been given force F, velocity V, and time T. This and this are taken as in fundamental units. If this three are taken as in fundamental units, then the dimensions of mass. Now look at this. This is a different kind of questions. Up till now, what we are doing is we have been taken a fundamental units. We have been taken as in fundamental units as in mass, length, and time. These are our fundamental units, and we are going to derive certain relations. Here the whole things has been changed. They have written that force F, velocity V, and time T. This three, force F, velocity V, and time T. These three are the fundamental units, and you require a dimension of mass. So what we can do is I can write that mass M depends on force F, let's say power A, velocity V, let's say power B, and time T, let's say power C. Clear? Now you need to find it out the values of the A, B, and C. This is what all I require. So let's say power dimensions of the mass, what it would be. Think, it's an M1 L0 T0. Yes. What are the dimensions of the force to the power A? Force is kg meter per second square. It's an M1 L1 T to the power minus 2 to the power A. So this is MA LA T power minus 2A, and time T to the power C. So time to the power C, it is an M0 L0 T to the power C. Yes. Now I need to just compare this. How it is? This is M1 L0 T0 should be is equals to MA LA T to the power minus 2A multiplied by T to the power C. So if I write it down, this is M1, sorry, this is M1 L0 T0. So M1 L0 T0 should be is equals to M to the power A L to the power A T to the power minus of 2A plus C. So this is A is equals to 1. Here it is A is equals to 1. then this is minus of 2a plus c is equals to 0. So if I put a is equals to 1 here, so this is minus of 2 into 1 plus c is equals to 0. So the c is equals to minus of 2, which will move on next side, it would be, and c is equals to plus 2. Got it? Yes. Now let's write it down. Mass, mass depends on, let's redo it. Made a certain mistake. Let's redo. Yes, we have not written about the velocity. We have not written about the velocity. So velocity to the power b. What is velocity? It's in meter per second. Meter, it is L1. Second, t to the power minus 1 to the power b. So this is L to the power b, t to the power minus of b. This is velocity to the power b. Now what I need to do is I need to just compare this two. So let's write it down on a very next slide. It is for mass, it is m1 l0 t0. For other quantities, we have a force, it's an ma la t minus 2a. We have a b, that is lb t minus b. And we have a time, that is t to the power c. So let's add it up. M to the power a, L to the power, here it is, this is a plus b, t to the power minus 2a minus b minus c. And here the terms are m1 l0 t0. So if I compare the exponents, it is a is equals to 1, a plus b is equals to 0, and this term as in minus 2a minus b plus c should be equals to 0. So when I put a is equals to 1 at here, so I can write 1 plus b is equals to 0 and b is equals to minus 1. Now I am having a value of a, having a value of b. Let's put it up here. So this is minus of 2 into 1, that's in minus, it's in minus 1 again, plus c equals to 0. So this is minus 2 plus 1 plus c is equals to 0. Minus 2 plus 1, it is minus 1. And so c would be equals to 1. So what I required is mass is equals to force to the power a, it's in 1, velocity to the power b, minus of 1, and time to the power c. If you wish, you can write it like this: f1, c is having a value of 1, time 1 divide by velocity to the power 1. This is equals to mass. So even you can derive up following quantities like this. So if you have been given that don't consider m, l and t as an fundamental, but rather consider this many quantities as an fundamental quantities and derive something, you can do it. You can use this application as well. I hope these things are clear. So am I clear up till this? Yes. Is there any doubts? No. Let's move on to the next. We are about to start the principle of homogeneity. Now before we start, what it would be, let's look. See it, what principle of homogeneity states? It states that only quantities having same dimensions can be added, subtracted and equated. It states only quantities having same dimensions can be added, subtracted and equated. Now What does it mean? Let's say if I will tell you that I am having a mass of 5 kg, I am having a length of 2 meter. I want you to add this too. I want that you should add 5 kg plus 2 meter. What would be its answer? What is its answer? You are thinking how this is possible. You cannot add kg and length. You cannot add it. Okay, so let's say according to the new numerical, an object having a mass of 5 kg, another object having a mass of 2 kg, you simply add this. Now you are okay with this. Your mind says it would be in 7 kg. Yes. So how this came? And why this is not possible? Because this cannot be possible because these are having different dimensions. Dimension of mass is difference, dimension of length is different, so you just cannot add this. And if you are supposed to add this, you need to rub it. But if two quantities are having the same dimension, look at this, of 5 kg and 2 kg, when when dimensions are equal, they can be added very easily. So this is what principle of homogeneity is all about. They said, now again read this, they said only quantities of same dimensions can be added, subtracted and equated. So if I say in an opposite sense, I need to say this, that if any two quantities are added, subtracted or equated, they must be having same dimensions. So if I write like this, x is equals to y plus z, here consider y and z are associated with a symbol of addition. They are added. So if they are added, they must be of same dimension. So dimensions of y and dimensions of z should be same. Even you just remember this, kg is equals to kg plus kg. Yes. So if x is equals to y or if x equals to z, then even this two must be having the same dimensions. So according to the dimensions, don't go into the calculations, according to the dimensions of x, dimensions of y and dimensions of z, this three must be equal dimensionally. I am talking about the dimensionally. So dimensionally x, y and z, these three are the equal. I hope these things are clear. So I would like to repeat one more thing. When any two quantities are added or subtracted, they must be having same dimensions. If they are added or they are subtracted, they must be of same dimensions. This is what we require. Is it clear? Is it clear? Okay, let's practice it, how that can be used. Suppose we have been given that let's suppose v is equals to b divided by t plus c. We know the dimensions of v, it's in velocity, so its dimensions or its unit would be meter per second. We know the t, it's in time, so its unit would be a second, and its dimensions you can write it down. Now I need to find out dimensions of b and c. I need to find out the dimensions of b and c. Now think in your mind what I could do. Which are two quantities that are related with the help of addition or subtraction? Think. You will get an hint. Think for a while. Can you think it? This is T. This is C. These two are related with the addition. So when these two are added with the relation, dimensions of time and dimensions of C would be equal. So even C would be having an dimensions of time. So if I have been asked dimensions of C, it is M0, L0, T1. So I have done one task. I am having in dimensions of C. Now you can rewrite this relation V is equals to B divided by T. So you know B is equals to V into T. What is V? It is meter per second. What is time? It's in second. This two have been gone and B becomes the meter. So if I have been asked the dimensions of B, it's an M0, L1, T0. Got it? Can you do this? Can you do this? Okay, let's look at the next question. Suppose I have been said that P plus A by V square is equals to constant. I know that P is the pressure and V is the volume. P is the pressure, V is the volume. I need to find dimensions. I need to find the dimensions of A. How could I write it? Can you write that P and A is having in dimensions of A? How many of you are thinking this? That sir, P having the same dimension as A. If you are thinking like this, you are not correct. This cannot be written because P is not associated with the A with an addition. P is associated with addition with not alone with A, but it is associated with A by V square. I hope these things are clear to you. So what I can write is dimensions of P would be equals to dimensions of A by V square. This two must be having the same dimensions, and when this two are having the same dimensions, I can write A is equals to P into V square. When I can just write A is equals to P into V square, when I can just write A is equals to P into V square, I can write it the dimensions of A. Do you know the dimensions of pressure? How could I get it? So I must know pressure is equals to force by area. Force, it is kg meter per second square. Area, it's in meter square. Here meter is, here meter square, so it is kg. This is m1. Meter, to 1 power left, this is L minus 1. Second square, it is T minus 2. And volume, it is meter cube. So this is M0 L3 T to the power 0. So dimensions of pressure, it's an M1 L minus 1 T minus 2 multiplied by V square. So this is L to the power 6. So this becomes M1 minus 1 plus 6. So this is L to the power plus 5 T to the power minus 2. This is the dimensions of A. Got it? So don't make a mistake. P does not having the same dimension as A. P must be having the same dimensions as an A by V square. Don't make a mistake. Is it clear? So let's move to the one more numerical, and you will do it on your own. Let's say we have been given that is equals to AT plus half into BT square. Now X is displacement, T is the time. You need to find out dimensional formula for A into B. So this is all given. X is equals to AT plus half BT square, that has been given, where X is the displacement and T is the time. You need to find out the dimensional formula for A multiplied by B. How could you write this? What all can be done? So first you need to find out the dimensions of A and B, and as soon as I get it, A into B, I can write out the dimensions of A multiplied by B. So at the very beginning, what I can do is, remember the word kg is equals to kg plus kg. Yes. So I am just going to compare this X with the AT because they must be dimensionally equal, because they have been equated. So I can write X is equals to A into T. So what I get it is A is equals to X by T. Now what is X? It's a displacement. So this is meter. What is T? It's in time. So it is second. So this is M0, L1, T minus 1. These are the dimensions of A. And what I can find it, X equals to half BT square. Again, half does not have any relation because it is a dimensionally constant. So B should be is equals to X by T square. So this is M0, L1, T minus 2. These are the dimensions of B. You need to find out the dimensions of A into B. You need to find out the dimensions of A into B. So when I find it out, A into B, here it is 0, it is 0. So this is M0. Here it is 1, it is 1. So this is L to the power 2. Here it is T to the power minus 1, here it is T to the power minus 2. So this is T to the power minus 3. So these are the dimensions of A into B. Now I hope these things are clear. Got it? Do you have any doubts? So we stop at this. Up till now, we have gone through the applications of dimensional analysis. What we have done from this units from very beginning. Let's recap it in a very summarized manner. We have started with the units, we have started with the measurement, we have gone through different systems. They are the CGS, FPS and SI systems. Then we have gone through the different category of quantities. They are the fundamental quantities, derived quantities and supplementary quantities. Then we have switched to the dimensions. We learn what are the dimensions, how for any physical quantity dimensions can be derived. Then we are using the applications, and we are using the dimensions in the different applications. We have learned 3 applications of dimensions. First, to check the correctness. Second, to convert a physical quantity from one system to another. And third, it would be to derive a relation among different quantities. And at last, we have gone through the principle of homogeneity. I hope this all things seems to be clear to you. Please do practice a questions. In a physics, if you want to succeed, you need to practice a question. This is the basic requirement of physics. You need to just go through these videos and attempt a questions. As many questions you can attempt. This will help to you. Thank you. Goodbye. Take care. Bye bye.